This is geometry, unit 4.4. We're going to prove triangles congruent by side, side, side. Prior to this day, to prove triangles congruent in the past, we've had to prove that three sides of one triangle were congruent to their corresponding sides of another triangle. And the same for the angles. The three angles of one triangle were congruent to the corresponding angles of another. That's how we used to have to prove triangles congruent. All six pieces had to be identified for triangles to be congruent. But today we're going to come up with a shortcut. We're going to take three sides and three sides, and if I turn them into a triangle, no matter what order you put them together, I'm guaranteed to have congruent triangles. The side lengths can't change, and that's what these little connectors allow us to do. But if you look, when you have the congruent sides the same, the angles have to be the same. So we don't have to worry about the angles at all. All we have to do is be sure that the sides match. And if we have corresponding sides that match, then I don't even have to worry about the angles. I can call the triangles congruent. So this is called side, side, side. So in this situation, we don't know anything about the angles, but we do know that AB has one tick mark, and so does RS. It has one tick mark. So they are congruent. BC has two tick marks, and it's going to be congruent to ST, which has two tick marks, because they have the same amount of tick marks. CA has three tick marks. TR has three tick marks. They're congruent. So TR. So I have three different sides that are congruent. So then we can write our congruent statement using the first triangle in any order we want. We're choosing to go in alphabetical, which is pretty common. A, B, C. So the second triangle, we went from A to B and then to C. We went up the one ticker, then we went down the two ticker. So we're going to go up the one ticker, so that has to be R, S, and then T. RST. And that would be a correct congruent statement. And we would have proved the triangle is congruent by side, side, side congruence. That's what we're going to write in our proofs. How did you prove the triangles congruent? You proved them congruent by side, side, side congruence. Let's come on down to our first example. Are these two triangles congruent? So you have to look at them. You have to study it. We see that JK is 8. We see that MK is 8. So JK is congruent to MK. That happens to be the first two letters is congruent to the first two letters. That's pretty common. Then we see the 9s. So I see that JL is 9 and ML is 9. So JL is congruent to ML because they're both the same length. But I'm looking for another set of numbers that match. I see that the 8s match, I see that the 9s match, but I have this other side, I don't know how long it is, and I don't know if it's congruent to this side of the triangle. Is this triangle that has this third side. The left triangle has a third side, and the right triangle has a third side. Are those two third sides the same length? Why would we consider them the same length? They're not labeled. We don't know the numbers. But if you look at it, it's the same side. We call that the reflexive side. We've done that before. We know that LK is congruent to LK because of reflexive property. It's the same side. It's in both triangles. It's one side that is the same in both. So we can put a tick mark in it because we know it's the same in both triangles. So KL in the left triangle is congruent to KL in the right triangle. So I know these triangles are congruent by side, side, side congruence. If you have three sides of one triangle congruent to three sides of another triangle, then the two triangles have to be congruent by side, side, side. Seem good? Pretty straightforward. How about this next picture? Are these two triangles congruent? When I look at this, I notice that ST has two tick marks. So does VW. They have two tick marks. I see that R or TR, however you want to name it, doesn't matter. TR has three tick marks and WT has three tick marks. So I have two sides that match and I have another two sides that match. That was kind of like I had over here. I had a pair of 8s that matched. I had a pair of 9s that matched. In this triangle, are the third sides congruent? And the answer is we don't know. We don't know if this length is the same as that length. Just because we have two sides the same does not mean the third side is the same. So if I take these yellow ends off of our triangle, okay, just because I have an orange the same and a purple the same does not mean that my third side, which in this case is really short compared to the really long side, just because I have two sides the same does not mean my third side's the same. So just because I have two sides the same in this picture does not mean those third sides, which are not the same. Over here it was the reflexive property. It was the same exact segment. Here it is not. So this would be not enough information. Not enough info. It's possible they could be congruent, but there's not enough information to show us that they're congruent, to guarantee that it's congruent, to prove it. Let's come on over to letter C. How about this one? Are these two triangles congruent? And a lot of people are going to say yes to this. But what are you saying yes to? What's congruent?
The tick marks are like stating that each side is the same.
All right, so you're saying that DG is congruent to HK because they have one tick mark the piece. Then from G to F, if you want to go that way, GF is congruent to KJ because they both have tick marks that are the same. And then FD is congruent to JH. They're congruent. There's no doubt about that. But look at the congruent statement that they gave us. They said that DFG, from going up the 2 tick mark side down the 3 tick mark side and back, is congruent to HKJ. So they're implying that the first 2 letters of HK is congruent to the first 2 letters of DF, but they're not. Okay, so the congruent statement is not written correctly, but I do agree that the triangles could be congruent. So if we would do them in the correct order, you can name the first triangle any way you want. GDF might be a good way. And it has to be congruent down the 1 tick mark, then the 2 tick mark. So this has to be KHJ. Therefore, we have DG the same as KH. And we have GF the same as JK. And we have the last 2 letters the same as the last 2 letters. So this was by side, side, side congruence. So no, this congruent statement was not congruent, but this congruent statement was. So you do have to watch out that the order of the congruent statement matters. There are 6 correct ways we could have written this. This was not one of them. These were not corresponding parts lined up. Come on over to D. Are these 2 triangles congruent? Go ahead and look at those. Make your determination. What do you see? I have a pair of 7s the same. So they would be the same. And then AC seems to be a length of 9, and that's in both triangles. So I have 2 sides of both triangles the same. But my third sides are not the same. I have a 7 in both. I have a 9 in both. I have a 4, but this side's a 3. So they're not congruent. I wouldn't even call it not enough information. The information is clearly here. A 3 and a 4, they don't match. This perimeter is 4, 7, 9. This perimeter is 3, 7, 9. They're different. So they cannot be congruent. Now we can even do this on a coordinate plane. We have triangle ABC and it's plotted. Negative 5, 1, negative 5, 3 to get up to B, and negative 1, 1 to get up to C. How long is AB? From point A to point B, we can count that because it's vertical. So that's 2. BC is slanted. I cannot count this distance. But I can do the distance formula. And to remind us what the distance formula is, that's when we take our x2 minus our x1 and square it, plus our y2 minus our y1 and square it. That's the distance formula. So working with B and C, if we would call this x1 and y1, and this x2 and y2, x2 is -1 minus -5 squared plus y2 is 1 minus y1, which is 3 squared. We're taking the square root of that. -1 minus -5. That's really -1 plus 5. So that's going to be 5 and a -1, which is 4. So here we have 4 squared. This is 1 minus 3. So we're minusing 3 from 1. So that gives us -2. That should be in parentheses. So this gives us 16 and 4. So this is the square root of 20. Whatever that is. We could simplify that, but we don't need to just for comparing. Square root of 20 will do. AC is the length of 4. 1, 2, 3, 4. From A to C is the length of 4. Now we have to compare it to the second triangle. So we're going to plot our points. D is at 2, -2. 4, -2. And 2, -6. There's our triangle. So we have D, E, and F. I can easily see that DE is 2 units long. So that matches. I can jump all the way down to the bottom, and DF, that's a length of 1, 2, 3, 4. That's a length of 4, so that matches. I assume this middle one might match, but it doesn't have to match. So let's go ahead and do the calculation. We're going from E to F, so we'll call this x1 and y1, x2 and y2. It really helps if you label your points. So x2 minus x1 squared, and y2 minus y1 squared. This gives us -2 squared and -6 plus 2. -6 plus 2 is actually -4. So this is 4. When you square -2, you get 4. And you square -4, you get 16. So 4 and 16 is 20. So square root of 20 matches square root of 20. By side, side, side congruence. That's why the triangles are congruent. 3 sides of one triangle are congruent to the corresponding sides of another. What would this look like in a 2-column proof? Remember, when we do these proofs, we don't want to pay too much of attention to the 2 columns yet. We want to convince ourselves by looking at the given information and what we're trying to prove. We know that WX, which might be 1 tick mark, would be congruent to YX, which could be 1 tick mark, because they're the same. I also know that Z is the midpoint of WY. Well, I look at WY, and it tells me that Z is considered the midpoint. Well, that doesn't tell me anything directly, but what does midpoint mean? It means right in the middle. It cuts it exactly in half. So I know that these two segments would have to be the same. If I have a midpoint, then I know I have two congruent segments. Now I have a pair of one tickers and I have a pair of two tickers, but I need a third bit of information. Do I have a third pair of sides congruent? The middle ones that are being shared. I know that the triangle on the left has xz and the triangle on the right has xz. Xz is exactly the same in both triangles. It's called the reflexive property. So now the triangles are congruent by side, side, side. They both have a one ticker, a two ticker, and a three ticker. So we'll come over here to our proof. We've already made our plan. So we know we have a pair of sides that are congruent. They're the one tickers. We could put an S over here on the side if we like. Sometimes that can be handy. I have an S because I've shown one pair of sides match. The other bit of given information was that Z, I'm sure that looks like a Z. Z is the midpoint of WY. That was our given information. But for Z to be the midpoint, what does that mean? What does that tell me? What am I going to say next after I hear Z is the midpoint? They're giving you a hint. You're going to talk about sides, WZ and YZ. Okay, we're going to talk about points or segments. But what's my reason these segments are congruent? If came earlier. So what was said earlier that makes these segments congruent? If midpoint, if a segment has a midpoint, then two congruent segments. You could probably shorten that a little bit by saying if midpoint, then congruent segments. But throwing in the word two is even better. More specific. So that's another S that we've just shown. So we have a pair of S's, pair of sides that are the same, another pair of sides that are the same. What's the third thing we need to do? This is giving us a hint. So what might we talk about here? Our reflexive side, the side that's the same, the side we haven't talked about yet, XZ, is going to be congruent to XZ. That's my third pair of sides. So my triangles, WXZ is congruent to triangle YXZ. From W to X, I went up the one ticker, then down to Z, over to make your triangle. So from Y to X, that's up the one ticker, down the reflexive side, and back to make my triangle. So that's my congruent statement. And why are triangles congruent? Right now, we really only have one way to prove triangles congruent. Side, 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 congruence. Here's our last one. Go ahead and think about how you're going to prove these triangles congruent. Pause the video, work through this one, come on back, we'll talk you through it. Okay, we're back. With our given information, remember, we're not supposed to look at our proof yet, our two columns. We're supposed to be trying to figure out how do we take this information with our figure to determine that the triangles are congruent. I am supposed to agree that IJ is congruent to HK, so I'm going to put one tick mark a piece there. IH is the same as JK, so I'm going to put tick marks there. Now that's 2 bits of information. I need to know something else. From a far distance, you could see that they're sharing a side. You could see that this side of the left triangle is the same as this side of the right triangle. So those triangles share a side. That's called the reflexive side. It's going to be congruent to itself. So now I have 1 tick mark, 2 tick mark, and 3 tick mark in each triangle. That's side, side, side. So that's how I'm going to prove the triangle is congruent. Make your plan before you write your proof. It's how you do all proofs. So we have IJ congruent to HK. And I have IH congruent to JK. That's my given information. That's where that came from. Now, notice in the previous example, we had something called the midpoint. We don't have that type of statement here. Nothing says that we have a midpoint. So we're not going to talk about midpoints. We don't have that. But I do have this side that's the same in both triangles. So JH, notice this, that J down to H. Looking at the triangle on the left, that goes from the 1 tick mark side down to the 2 tick mark side, J to H. In the other triangle, the 1 tick mark side up to the 2 tick mark side is H to J. So that's why they changed the order, because you're going from a 1 tick side down to a 2 tick side. So we have to go from the 1 tick side to the 2 tick side. That's in a different order. But that's still the reflexive side. Reflexive, POC. That is not an if-then statement. It's just a reflexive property of congruence. Notice that up here was 2 sets of S's. 2 sets of sides that were congruent. This was a 3rd set of sides congruent. Now I have enough information to say that triangle HIJ is congruent to triangle JKH. And what's my final reason? It's really the only reason we have so far. Side, side, side congruence. This is the only way we know of so far. In the future, we're going to know 5 different ways to prove triangles congruent. Today, we really only know 1 way to prove triangles congruent. And that's our proof. We found all the sides that match. They gave us 2 pairs, so that made it really easy. We identified the 3rd as the reflexive because they shared it in the picture. So the triangles were congruent because 3 sides of one triangle were congruent to 3 sides of another triangle.